guys, welcome back to my channel, Chem with Jax, where today is another episode of Allies in STEM. And I'm super excited for today's episode because I am going cross country all the way to Hawaii. And what I have here today is Dr. Jay Brett, and they are a physical oceanographer, and I'm excited to learn all about what they do. So, Dr. Jay, are you here?
Hi, it's great to meet you, Jackson.
It's nice to finally meet you. So, tell us all a little bit about who you are, what you do, and just everything about physical oceanography.
Sure. So I am a postdoctoral fellow at the University of Hawaii, Manoa right now. I am a physical oceanographer. What that means for me is that I study the physical processes in the ocean that rearrange the water. So there are a lot of components to that, obviously, because the motion in the ocean happens at all scales, from as big as the planet on down to teeny tiny little turbulence at very small scales. So physical oceanography can encompass all of that. What I do is I simulate regions of the ocean to try to understand how sort of medium-sized motions rearrange things like heat, salt, and phytoplankton. Yeah, so previously I did an undergrad in math and physics at Skidmore College, and then I did my PhD in a joint program between MIT, the Massachusetts Institute of Technology, and the Woods Hole Oceanographic Institution in Massachusetts. And then my current postdoc had a portion of time that was spent at NCAR, which is the National Center of Atmospheric Research, for atmospheric research, which is in Colorado. So yeah, I really enjoy my work. And I really enjoy getting this opportunity to talk about it with other people.
That sounds super amazing. It sounds like a lot of hard work. So you've been pretty much across the country from Boston to Colorado and now Hawaii. That's amazing. What was your favorite part? Which city, I guess, has been your favorite part or region?
Oh man, I think I really liked Boston. I grew up in Connecticut, so it's not very far from where I grew up, and the culture is very similar, which is really nice. And also because I went to undergrad in upstate New York, which is relatively small towns, basically, being in a larger city like that was a lot of fun.
One thing that kind of stuck with me was that you mentioned the convection of the ocean and stuff like that, and I was wondering does this have anything to do with hurricanes? Because I'm from a city that gets hit by a lot of hurricanes. So I was just wondering if that had anything to do with it, or maybe I'm just thinking about it a little wrong.
No. I personally don't work on hurricanes, but a lot of my colleagues certainly do. They're very important. An important thing about hurricanes is that they are mostly in the atmosphere. Right? They're mostly an atmospheric phenomenon, but the ocean does matter. A lot of the energy of the hurricane has to do with their interaction with warm water in the ocean. So the temperature of ocean water can change how big a hurricane gets and what direction it moves in.
What are you focusing right now on your research? What's your main focus?
Yeah, so the project I'm part of right now is funded by the National Science Foundation, and it looks at how upper ocean physics changes under a warming climate at relatively small scales for the most part. So we're talking about, sort of 1 to 100 kilometer scales. I know that might not sound small, but for the ocean, it kind of is getting there. And then how those changes in physics near the surface will affect the growth of phytoplankton. So phytoplankton need both light from the atmosphere coming down, right? And they need organic nutrients that are more prevalent in the deeper ocean. So those have to get transported upward. So in a future climate, the upper ocean warms, and the sort of physical conditions that can bring those nutrients up change. And we're trying to quantify how much they change, basically.
This is probably going to be a little bit more of a chemistry question, but ocean acidification, how does that play a role into does it affect at all your studies?
Yeah, so Ocean acidification is really important for carbonate chemistry in the ocean, and that does affect certain types of phytoplankton. It will basically inhibit their ability to grow because they won't be able to form their carbonate structures the same way in a more acidified ocean. But my current research does not look at that in particular.
All of that research is super awesome and super interesting, but now I want to know a little bit more about you. So do you have like anything that you like absolutely love doing besides science?
Yeah, absolutely. I spend a lot of time doing like sports hobbies. So I study Brazilian Jiu-Jitsu, which is a martial art. It's super a lot of fun. It's most similar to wrestling, I think, that people would have seen before. Not like WWE wrestling, but like college wrestling. So that's a ton of fun.
I automatically did think WWE wrestling.
Right? Most people, that's kind of different. So I spend a lot of time doing that, usually, obviously not currently with the pandemic.
Yeah,
but yeah, here in Hawaii, I've also been fortunate to pick up some country line dancing, which has been a lot of fun. There is
in Hawaii.
Yeah, I know it's unusual, but there is there's a group called Blazing Saddles, which is a queer country line dance group that I joined here when I moved, and so that's been a ton of fun, learning a new kind of dance for me and being around like intergenerational queer people all dancing together. Super awesome. And I've also been learning how to surf, which is the one thing I can still do right now.
That's awesome. I was actually just going to ask you that if you've like been curious at all about surfing, because I know that like if I ever visit Hawaii, that's like the number one thing on my list to do, learn how to surf.
Oh yeah, it's super fun. It's like, if you've ever been like skiing or snowboarding, it's kind of the same thing, in that you're like sort of feel like you're flying because you're falling a little bit and like moving along. It's super great. My favorite memory of surfing here is one day I was out there and I caught a wave and I'm going towards shore and there's this huge rainbow like right in front of me. And I was like, this is the Hawaii dream. Like, so amazing.
So do you have any pets or anything keeping you sane there at home while we're in quarantine?
No, sadly, Hawaii, well, plus minus, Hawaii has no rabies on the island, so bringing pets out here is a very complicated process. So my partner and I have a cat, but he is actually with my in-laws in Connecticut, because my partner moved out here for a job that he found since I've been here. And we only expect to be here for about a year. So it didn't make sense to go through the whole process of bringing our cat with us. So we miss him a lot, but he is having a great time with the in-laws who absolutely spoil him.
Yeah, grandparents can sometimes be the best because my dog will absolutely just run away from my wife and I when we go visit my in-laws' house. And he's just like, Grandma, I love you, and like, forget about you guys.
Yeah, exactly. So it's okay, you know. It makes us sad, but he's definitely doing really, really well.
Making our way back to like STEM and stuff like that, where did your journey begin? Like, how did you get interested in like the field you're in now?
Sure. So I was originally, when I was a kid, I thought that I was going to do math somehow for like my whole life. That was, my best subject in school and that kind of thing. And then when I hit high school, I decided, no, not math. It's going to be physics. Physics is this really cool thing now, and I like it a lot. My teachers are great, right? And so when I go to college, I'm going to major in physics, which I did. But I really liked math a lot. So I was at this funny intersection where I was like, what kind of physics uses a lot of math? And so I thought I would get into statistical mechanics. So stat mech is really useful for soil science, granular materials, and fluids as well. So I ended up doing some research with a professor who was part of our physics department, but was a physical oceanographer. And so we did some fluid dynamics experiments and I really enjoyed it. And so he encouraged me to apply to the grad program that I ended up going to, which is the one that he went to. So that's kind of how I ended up in oceanography. Yeah, the particular research I did for my PhD work was pretty heavy into the math. It was really focused on using dynamical systems methods from mathematics on fluid systems in the ocean. So it had to do with chaos theory and how the stirring in the ocean can be chaotic and what that means for the stuff that gets moved around there. So there was a bunch of math, which made me really happy. And I also got increasingly interested in the ocean for its own sake over that period of time.
Wow, that's really cool. Like, I didn't even know that there was like physics and like, well, like obviously there's physics and everything, but like really like specific physics for like ocean and stuff like that. I thought it was more like weather-based for some reason. I don't know, but this is really awesome.
Yeah, that's great. Yeah, the physics in the ocean is very much like the physics in the atmosphere. So there's a lot of crossover. And people just don't think about the ocean as much unless you happen to live there, right? It's not a part of everyday life like the weather is.
If you don't mind talking about like, what was your experience like as a queer person in STEM?
Yeah. So a large part of my experience when I was in school as a queer person in STEM was navigating the fact that I was out with my peers and my friends, and I was closeted with my faculty and advisors and all of this, which I think is happening less over time as people are more and more open and, you know, mainstream culture is moving forward. But when I was in high school, we were still arguing over marriage equality. So it was very much like, you know, not really talked about, not really comfortable. Yeah. So the nice thing now is that now that I have my PhD, I feel much more comfortable being like, no, I'm queer, use they, them pronouns, like, this is who I am. We're going to make things move forward faster. Everyone who can be out can help push that needle a little bit.
Yeah.
So yeah, so it's kind of a funny line to walk. But I've been fortunate that I have almost never gotten any pushback or personally felt, you know, discriminated against. And there have been things that we have worked on at various institutions I've been at. Woods Hole has a You Are Welcome Here program where they have printed out these cute little like postcards, and everyone who's in the know and an ally has them like on their office door or tucked into a window somewhere, which makes it feel much more welcoming to hang out. And at both Skidmore at MIT and now here at University of Hawaii, while I've been there, there's been a push for gender inclusive bathrooms on campus, which I've helped out with a little bit as I've been able to. So it's been really positive to like see things progressing as I've been going through the system myself.
Last thing on the topic of STEM, since you've been navigating this world a while,
Yeah.
In academia and stuff like that, what is something that you would like to see changed in STEM?
Yeah, so I think one of the big challenges in sort of master's and doctoral training in STEM is that your faculty are not trained in teaching. They're not trained in pedagogy as a general rule. And the people who sort of run the programs on a higher level are often faculty who get promoted and have to learn on the job. So this can cause a lot of challenges. There's been a lot of effort in the past few decades on STEM education in colleges, right? And how to make that better, more inclusive, more active learning methods, all of these things. There has not been as much work done on the graduate level of education. And I think that this causes a lot of problems for students because it's very hard to be clear about your expectations for students just out of thin air, right? Like you have some idea of what you want your students to do and you try to tell them and it goes wrong, right? And then what do? Do you fail like half the class? Like, So I think that there is a lot of room for improvement in graduate education in terms of both sort of allowing all students to do a better job and to feel less stressed as they do this very difficult work, and to improve inclusion and equity as a whole. I think if we got better at pedagogy and at very clear communication of expectations, we would have much happier and students with higher retention.
One last thing. So I know that we had an experiment plan. Are you ready to show me? Because I have my stuff here. I just need to grab the eyes.
Okay, so I've set this up for kind of a double experiment. So I have 2 cups here with salt water in them, and 2 with fresh water, and then I have some dye.
Should I have already put the salt in the water?
You can do it now. It's not gonna matter. Just put some salt. That's plenty.
I'm sorry, online the procedure said 7 teaspoons, so that's what I did.
Oh my God, okay.
I was like, wow, that's a lot, but
it is. But you'll get really clear results.
Okay, great.
Yeah, so then you take your ice, right, and you put 1 ice cube in each of them.
Okay.
At like as close to the same time as you can, right? Okay, so the question is, whatever, I did it. The question is, which ice cube will melt first?
Okay, I would expect the salt water one to melt first because freezing point depression.
I'm just going to show you. This is salt ice.
Salt ice?
Dump it into the other ones. I haven't gotten great results with that, but it happens. So, okay. So you said you think the salt water one will melt faster. We use salt in the winter, right, to change the freezing point of ice so that it'll melt faster. So what I've done is I've also taken these salt ice cubes and put them into salt water and fresh water, which I have not yet gotten good results with. But so this is a salt ice cube in salt water. This is a fresh ice cube in salt water. This is a fresh ice cube in fresh water, and then that's a salt ice cube in fresh water. So the fun bit about this is that it's really a physics question. So if you put some dye, is that visible? Yeah. Onto one of your ice cubes that's melting, you can see where the meltwater is going.
That is so cool.
Yeah, so this is a saltwater ice cube in fresh water. So the water that's coming off is sinking compared to the water around it. Right? So did that sink to the bottom? Or did it stop somewhere in yours?
Oh, it sank to the bottom. I think I missed the ice cube though.
That could happen. Right? So, okay, so I'm getting a little bit of some condensation, right? So if I do it on, this is the freshwater ice cube in fresh water, and we can watch it and it's sinking to the bottom again. But if I do it on the one that's a freshwater ice cube in salt water, is that visible?
It's kind of just floating on top from what I can see.
Yeah, there we go.
Oh, that's cool.
Yeah, so what's happening here is salt makes water denser. Right? So the water in this cup is denser than fresh water is. So even though the water is, oops, dripping paint everywhere. So even though the water that comes off the ice cube is cold, which also makes it denser. The salt affects it more. So all of the melting water from the ice sits in a top layer, which makes that top layer of water very cold and slows down the ice cube from melting.
I really like this one because I like changing colors of liquids. Weird.
Yeah.
Even though I know it's food coloring.
Well, there's a cool one if you want to do an ocean acidification experiment sometime, where you can put a pH indicator in the water and then blow bubbles into it, and it'll actually show.
I actually have a pH indicator. Do you want to see it?
Yeah. I mean, if you have one.
I have universal indicators because obviously everybody has universal indicators, and I shouldn't do that or goggles on.
That's how we know you're a chemist, is you have your universal indicator at home.
I do. I have a blowtorch. I have some chemicals. I just ordered some sodium acetate.
Nice.
Because why not? Normally we do this with like phenolphthalein, and it goes from pink to clear. That one's really fun, but I love this one better because it starts like blue and you don't expect it to change the final color. I'll just leave that one as a surprise. So, can you see that?
Yeah.
Is it like still pretty clear, or is it?
It's mostly clear, but it's a little bit blue. Like, it's obviously not just water.
Yeah. Okay, cool. So for people at home, we're going to do that makeup thing. There we go. This is universal indicator.
Yes, be safe at home, guys.
Be safe at home. Never touch this without gloves or goggles on like I was about to do. All right. I'm going to add just a little bit more just because it's a little bit light. That should be good. Oh, yeah, it's dark now.
Okay. There you go.
So for anybody who doesn't believe that we exhale a certain percentage of carbon dioxide.
Yeah. So it takes a fair amount of work usually to do this. And when you do it with a bunch of kids, it's fun to see who gets it first.
Oh, it is. Oh, it's green now.
It's green now.
So we're at neutral, pH of 7.
And don't inhale. Indicator.
That would be bad.
You can make an indicator by boiling red cabbage, and then it is a safe to eat indicator.
Yeah. We've done that one too. That one's really fun because kids don't expect that it can actually change color. Right.
Sorry. You make people laugh enough, it changes their carbon dioxide as well.
So it's kind of like a yellow. Yeah.
Yeah. So that's what's happening in our oceans, but like over lifetimes instead of minutes.
So, do you think car and plane and train emissions in industry also speed up that process? Oh,
absolutely. We have run an unintentional experiment with the stay-at-home orders that we've done, where individual use of cars and planes has dropped off by about 50%. And the carbon dioxide in the atmosphere did slow its rate of increase briefly, but only by about 7%. So this has been a nice experiment that shows that individual action on climate change has limited effects. If we want to do something about climate change, we really have to regulate large industry in order to bring down overall emissions.
Dr. Brett, as a thank you, I did mail you something, so I hope you received it in time. Oh, you did? Yes.
I did.
Okay.
I did. It's great. Okay, so.
This is just my thank you for your time. I was a little worried you weren't going to get it in time.
Yeah, well, it takes a little time to get things to Hawaii.
Yeah.
All right.
I definitely couldn't drive there.
No. That's so nice.
So this is the allyship pin made by Yas. He's also an artist, so he sells all types of pins on his website, and I love this one, and everyone should be an ally, or can be an ally. So
That's
this is just
awesome.
my thank you for joining
Thank you
me.
so much.